Hey, welcome back. So this is part two of a video series that I'm putting together, just built as a tutorial of things that I've learned over my career. And really I'm trying to speak to anyone who works in tech, whether you're a programmer or whether you're not a programmer, but you need to work with data, and have just kind of grown frustrated of not being able to solve some of these problems yourselves or not having the tools you need to solve these problems yourselves. So to kind of recap, in the last video, we covered some ideas like, writing custom code for every problem isn't always the answer. And instead borrowing from the ideas of the Unix philosophy, just the idea that you can have a lot of small specific tools that do one thing and focus on one thing and does it very well. And these tools also build on the flexibility of kind of having a universal format of inputs and outputs, which is just text, and being able to connect these programs, right? And so that the output of one program can be the input of another program, and you can glue these small components together into bigger ideas. And in the last video, we demonstrated some ways where your computer probably has a lot of these powerful text-based processing tools already. And we looked at a few examples just based on what should probably already be on your Mac OS X system or your Linux system. I did mention for any Windows users that I know that there's the Windows subshell for Linux out there. I've not personally gotten a chance to use it or vet it or try it out. So either someone let me know if that works or doesn't work, or better yet, if somebody wants to build on this video and demonstrate, this kind of presentation and doing it in Windows and getting set up, I'm sure that would be great for someone who's interested by these ideas but wants to do them on Windows. So anyway, now this video is more focusing on tools that were built specifically thinking about data that comes in other formats, and that tools that are built around these specific formats. So we'll look at JQ, which is for JSON, and JSON is probably what you can expect out of most APIs these days. It's a subset of JavaScript that's useful for encoding data, and so you can send objects or documents, JavaScript documents, and it's just a format that's easy for humans to read and easy for computers to parse. But then there's also PUP, which does something very similar to JQ, but works for HTML files. And then csvkit, which I think that probably is self-explanatory. It is really just really useful for working with data inside CSV files, and a lot of tools for working with CSV files. There's a couple of other tools in there that I've looked at in the past, and they're handy, but this is just going to focus on those three. From the repository as well, again, this will be public and you should be able to get to it. I have the links to the installation pages for each of these, and those are things that you should be able to install on your own computer if you want to, or if you have something called Docker or are willing to install Docker on your computer. I've also made an image here, which you can basically install all the tools that you need, and it'll have pip and csvkit installed, and there's a script already put together here to help you build this and to run it, so that you don't actually end up having to learn a lot of Docker if you don't want to. So that's all there. And so let's dive into it. So let's start by looking at JQ. So the whole idea around JQ is that if you give it some kind of input, so that's either a file that contains a JavaScript object, but more likely it's going to be a stream or the output of some other program. So for example, if in the last video, we used curl for making HTTP requests, and the output of curl to an HTTP API that responds with a JSON response, we can pipe that in to the standard input of JQ. And then it will also take some selectors, filters, transformers. It's got a little kind of a little domain-specific language, or a little language for getting stuff out of that JavaScript or that JSON value. And then what you get back is you can get a few different things. You can either get more JSON, or you can get something that's inside, like maybe you need to pull out an object inside of that JSON, or you can just turn them into raw numbers or raw strings or just some other kind of expression. So for an example of that, here, so echo is a program that will spit whatever you give it back to the terminal. And so that's helpful for, I just want this string and I want to pass it to JQ. And then if you recall from the last video, this is the pipe. So echo is just going to reprint this back, and we're going to pipe it into JQ. And so what we have here is an object. This is foo, and the key foo has a value. It's associated to a value bar, and this is called a string, right? So it's just a word. So if we ask for .foo, we should get bar back, right? And if we want, we can come over to the terminal over here. And so JQ is already installed on my computer. So again, if we do foo and assign bar to foo, so that gives me just that object printed to the screen. It's just words, text. If I ask for foo, I get bar back, right? If I just ask for dot, that means the whole thing, right? So this dot is really important in JQ, and it just means this is my current context, and then I can access things in my current context. So let's go back. I can also do things like build bigger objects, and if I wanted to get this object inside, I can ask for .stats and it will return the object. So let's come bring that over here. And if I paste that, I should just get the object that's at stats. And if I want that object to be on one line, I can just do -c. Or if I want to access the property of an object, I can do .stats.hp, and I get that back out. I can also do something like this pipe. I can do piping even inside of JQ. And that really just kind of sets up the new context. So the new context after the pipe is the object at .stats. And that's another way to get the same thing. So let's go back, which we just demonstrated that example. So I got ahead of myself. The other thing we can do too here is demonstrating -c will make everything be on one line. The other thing that you'll notice here is that I'm not using those dots anymore. What I am doing is I'm telling JQ, this open curly bracket says I want to make a new object. And I want a field named name whose value is also .name, right? So let's take that back over here. I'll show you what I mean. So if I come back over here, let's clear my screen, and pipe that all into JQ, I get a big object. And so then I can ask for, if I wanted to make a new object and I would say name is .name, I would get that, right? If I wanted to just say something like first name, I can rename fields this way. But in this first example, I've got a new object whose key, well, the value of the key is going to be the same thing as the name of the key. And so there's a little shortcut that if I am just accessing something and naming it the same key, I can just do this. So that's the example that we're showing over here. So that's how I can get values out of JavaScript objects. The other thing is we can do expressions. So there's functions inside of JQ. So rather than having to like set up a JavaScript environment, or command line can be a JavaScript environment. And add is a function that comes already built into JQ. Add is expecting an array. You can think of an array as just a list of things. And in this case, I've got a list of numbers, or a collection of numbers. So if add is expecting an array and I send it that array, it's going to do the calculation for me and pass this array into add, and add will respond with 15. The other thing we can do is we can use a function called map. And map is a function that it expects a list of things and an operation to do on each entry in that list of things. And so in this case, inside of map is going to run on each entry in my bigger array here. And so the program, if you will, the instructions that we want to run for each entry is we want to get the name out of each entry, and then we want to pipe that into this function called length. So I'm going to get the name of each entry and then get the length of each. And what map does is it creates a new list that is the result of transforming the first list. And we can see if we do the same thing, this is the name of the folks in my family and my boys, and we get the length of everybody's name. Yeah, and if you're this sort, you can certainly leave a shout out or a thought from my wife. She's the one girl in the family full of boys, so good for her. Anyway, So that's how we can do operations on things, and so we don't have to just get JavaScript back out. We can get numbers and values back out. So there's a couple more examples I want to show you here. So we'll come back over to the code and we'll look into JQ. So right now we're in the bash folder from the last exercise. Let's go into JQ, and we have a folder called extract. Let's look first at, let's look at my first one here. So this is the station code weather. So again, more instructions. If you read this yourself later, you'll get an overview of what's going on and what tools we use. But first what we're going to do is I have already pre-saved a file with some station codes in it. And if you're not familiar with this, like this is just how, each city, usually it's by the airport or by a university or something like that. They've got a station code to run the official stats for that city on the weather. And that can get reported. So for example, here's the station code for Seattle. I think I've got Portland and Denver in here, a few other ones. So anyway, I've got that list of station codes. And what this is going to do is take that as input. And I have in here pre-recorded from our API saved so that, if for some reason this API goes down by the time you try this, you'll be able to run it on the raw stuff. So don't worry about that for now. But one of the things that we're using here is weather.gov. They've got an API available, and it's just open source and it's fast. And well, I don't know if it's open source, but it is free. But it lets us ask for just what the weather is at any one of those stations. So we can see here, I'm going to spit out that, not this. Let's get rid of this right here. So what we have here is we're going to take out input, which is our list of codes, and xargs is going to run a program for each entry in that list of codes, right? So basically this is just saying, I'm going to give you a list of, what was it? I'm going to give you a list of 8 things. So run all of this on the right for each of those 8 things. And so the program that will run here is curl. And xargs is going to let me replace something. So that's what this -i means. And some other folks are like, there's a convention you can use % symbol. I like to use this for some reason, open and close brace. But what we can see here is curl is going to make a web request to api.weather.gov and is going to replace this here with each line that I have here of my station codes. And so then I'm going to get the latest observation for that city. And let's just run this without running it in a JQ, just so you can see what the raw data looks like. So let me get to the end of the line and comment that out. And I'm going to comment out all of this just so you guys can see what we get back. So you can see I'm getting a bunch of JSON back out, right? And let me scroll up. Actually, let me zoom in on this tab and then scroll up. And so you can see for each station code, the weather.gov API sent me back some data. This happens to be in JSON LD format. And that matters to a few people, not a lot, depending on what your audience and what you work on. But since it's JSON LD, we can parse that. So in this example, they sent me back way more data than I actually wanted. Maybe I just want a subset of that data and I can send that to a specific program that I have set up to display the weather, or send it to like a Raspberry Pi or something like that. So what we'll do instead is I'm going to build 2 objects and I'm going to glue them together. So my first object is I want the geometry. So there's a field called .geometry, and that has a field inside of it called .coordinates, right? So in our top level payload, we've got a key called geometry, and that has an object with a field called coordinates. And then we pipe that. And so coordinates here is an array or a list of things. Let's see if I have an example up here. So if I scroll up to the top, I should find, here we go. So here is for the weather station at SKMD. There has a geometry object right here, and it's got at the field coordinates an array. So I want those values. And you saw that there, the latitude and longitude was just 2 entries in a list. So dot bracket 0, this is an indexing operator. I want the 0 want the number in the 0 position. And for folks that are not familiar with programming languages, and many programming languages, when you count a number, a list, we start counting from 0 instead of counting from 1. And there's a reason for that. It's history. It's not super important to know. But if you can just get it in your brain that, for certain languages, when you start counting into a list, you start from counting from 0. So we want the thing at the 0 position and the number at the 1 position. And so that gives me my latitude and longitude. And now I have an object built up called lat and long. But I want more fields than that. So everything between the parentheses is one object. And then I'm going to merge that with everything on the right here with the plus sign. So I'm going to take out the properties and build a new object. So here, there's a field already called station, and I want to keep the name station. Here, there's a field called text description, and I want to rename it to summary. Here, there's temperature, and it's got a nested value called value, and it's got some other extra information in there that I don't care about, so I'm just going to rename it to temperature. And then here, I've got cloud layers, and cloud layers is, let me see if I've got an example here. So cloud layers is a list, and that list has objects. And, you've got all this extra information. So like few clouds, 910, whatever that means, unit per meter, maybe. So that's cool. I don't need to know all that. I just know that we've got few clouds and scattered, right? So what I want to get those strings out. So cloud layers, and then I'm going to use map to pull out the amount field. And then I'm going to, at this point, I've got a list of cloud values. Now I'm going to join them together with a comma followed by a space. So when I run this program on everything, I've got a nice short list here. And let's make this a little easier to see. So now I've just got small, simple objects that show me, and you can see here's how we built up that list. And this is all in JSON format. We've got one object per line. If I took off this -c, it would try to format it for me in kind of a larger, more readable version like that. And the API is, I guess right now being a little funky. So that's why we have the pre-recorded options. They're saved in the repo and you'll be able to use them. But anyway, so I've got this if that's more helpful for me to read. But if I'm working with data, it's kind of nicer to have each on one line. And I can save this into a file and deal with it in another program. Or I'll show you later, I can pipe it into other programs that know how to take in new line delimited JSON and do new things with them. So then let's see, extract from list. Is that something that I forgot to remove? Yep. Okay, so extract from list is something that I'll correct this. This is another typo. I won't actually have that example. But that's my JQ example. So let's move over to pup. Pup is just like what we saw with JQ, except it spits out HTML. And if you're familiar, so CSS is a language that we use for, it's called cascading style sheets, but it's a language that we use to specify how the browser should customize the look and feel of a page. So colors, typography, layout, things like that. So we can use the same language that we use to target certain elements for styling and use it to pull elements out of a page. If you've ever worked with something called XPath, XPath is another language for getting through XML-like documents, and HTML is XML-like, to pull things out of it, right? So we don't have as much power and built-in functions as we had in JQ, but it does know how to just pull things out of web pages, and it can print them out in various formats. So here's an example. We've got a site called Hacker News, which is it's kind of like a nice reader on top of the Y Combinator Hacker News news aggregator page. So I can send a request to Hacker News and get back just raw HTML. So let's show that example. So this is all the JavaScript all the HTML for the content that's currently on that page. But I want to be able to pull stuff out of it. So what I can do is say there's there's an object, or rather there's a node inside that page with the ID of entries. And then there's going to be many entries inside of them. Each entry will have a class name. That's what this dot means. So so things with ID should only ever return one thing. Dot entries can return 0, 1, or many things. And then each of those might have a class or elements with the class of dot entry. And then each of those will have a link inside. That's what the A means. But I can give it the pseudonym last child. So I only want the last link an each entry node that's also inside of each entries node under this page. And then this last thing here is I can either spit out the text, I can spit out a certain value, or I can take this whole node as a JSON object and print it out. So let's do that. Cool. And my kids just showed up. So I think that's going to have to be the end of this video. This is life at home now. But the whole point here is, great. So I've got a way to pull things out of web pages. And that's really handy if you're doing just data extraction or having to work with a lot of pages. And then I can also send that to JSON, and then like JQ will let me work with that. So here's a more relevant example. So I've got here a developer guide from Google about structured data, which is can be encoded in a format called LD-JSON. So what I can do instead is try to ask the page for get me all LD-JSON in a page, and then just get out the raw contents of that. And then I can pass that directly into JQ and get out the things that are inside. So here's an example. So this can be really powerful for anyone who works with structured data or needs to be able to pull a lot of information out of pages. This is pretty common in SEO or working with like large businesses. I write about this on my blog here in local domain NAP audits. We talk about this concept as well of just pulling things out with JQ. And we've got a lot of examples of like just pulling store address information out of pages. So it's the same concept, just applied in a specific problem. So, all right. I didn't know my kids were coming down this early, and I hope, I hope I didn't ruin your day by having to listen to a bunch of, they're playing Mario Maker and having a good time. And that's how we're getting through the big isolation time here in the pandemic. So the next video, whenever I've got some more quiet time, we'll focus on csvkit. And that's a really nice toolkit for working with CSV files. And they can talk to, they can work with the JSON format that we've just described here with JQ. So in the next video, we'll talk about csvkit. We'll talk about just a fun, silly example I made up with Dragon Ball Z. And that'll basically be the end of this deck. So hopefully this section here was useful. Again, I use JQ all the time. I also built a little tool, which I need to resurrect. There's like 100 different ways to do this, but I've also built like an interactive way to play with JQ. And I want to say that there also exists the JQ Playground. Yeah, so here's a web version where if you just stick JSON in here, you can practice playing with JQ, and I'll put a link to this where you can get to it. But yeah, JQ is great, and I use it a lot for just getting jobs done. And so the next section is actually pretty exciting, just for all the things you can do with CSV files, and then how we can glue them together in bigger context. So see you on the next one.